Okay, so this is going to be another update on the floor 3 solver. So as you can see, I've got up to 117 levels now. So I'm pretty impressed with that. And what this video is going to go over is how I managed to get there, like what methods I've added since the last video. So basically we're just going to take a look at the code. I'm not actually going to be running anything here. Just going to talk about what I've added and then where like the next plans are. So I'm just going to zoom in a bit so it's a bit easier to read. So I mentioned I was going to try and get it to go like around the outside and basically guess where it was going to go. That's this bit right here. So you can see I've put this inside a function that basically will let you know that it's using riskier methods, because these methods can make mistakes. In fact, when I ran it on the levels, it made, I think, mistakes on 3 levels. Like it would think it had a solution because the board would be filled, but really it never. So I'll get to that at the end anyway. But basically, what these 2 functions do that I've added. So there's a function right here, connect adjacent ends, and then there's a function right here, traverse outer edge. This connect adjacent ends, thinking about it now, I'm pretty sure this is a safe method. It's not a risky method. In fact, I'm going to move that right now. The reason being that the floor 3 problems, I'm pretty certain, are meant to not have loops. So if we look at the board again, so like something like this red here, it couldn't do that because that would be a loop. This right here, it would be like basically you can't have it where where you have like 4 squares next to each other be all connected, and you couldn't have something like we try and find a more open board. I think we need like 3 squares open for this. This might work. So you couldn't have something like this. So like it couldn't go here because of you can't see my mouse for some reason. 1 second. I'm not sure how to fix that either. But basically, this this corner above the start point, you couldn't have that because that is going back to the start point, and I'm pretty certain that there is not a possibility. And in like the actual rules, is not meant to be allowed. It is allowed in floor 3. Like there are some way you can solve them with loops. But from looking into it a bit, it seems like any that you can solve with loops, you can also solve them without loops. Like they have multiple solutions. So I'm going to try and stick to the like official rules that don't let you have loops, because I think that will produce, like that'll be easier to make an algorithm to solve. So that's why I've moved this out of the risky methods. Now the actual really risky method is this traverse outer edge function, which is the main one I've added. So connect adjacent ends, all that does is if you have so say you've got like this red one right here, connect adjacent ends just joins these 2 ends. So obviously in this case it's not risky, but I can't actually show this because the game doesn't let you, but say if like the blue went to like here, and then while that was there, the other blue went to there, it would then connect them. So like, because the board can be filled from either side in my simulation, whereas obviously in the game it has to be all flowed like one way to the other, like one end to the other. So yeah, I'm not sure how much of a risky thing that is. I don't actually think it is risky because, like I say, with the rules, but yeah, that's why I added that anyway, just to connect ends. There was a specific level where 2 ends were like right next to each other, but they had choices. They could either go like, they could connect to each other, or they could both go like left or both go right or something like that. So this was just to help fix that particular level. I think it was like I think it was one of these levels, like one of the 6x6 somewhere, but I don't know, I probably won't be able to find it, but basically that's what it does. Now the main function I've added is this traverse outer edge function. Like I said, it's risky, so that's what we're going to go through now. We're going to go through how it works and what it does, why I added it, and basically I want to be able to get rid of this. I added this because I was interested in seeing like how many it would solve with it, and basically it worked quite well. It added like almost an extra 20 levels to our solve, like possibilities, but it also gets them wrong, and I wanted a more sort of a more rigorous way of doing it. So let's go over what it does, and I'll talk about what I aim to do in the next one. So basically, it loops over this I right here. Now, I is just going to be so normally we loop over I and j, but in this case we only have to loop over I because we're only traversing the outer edge. We can use I as our I parameter, and we can also use it as our j parameter right here. So you'll see we have like a whole loop here and then a whole bit here. Now this one is like the I0. So if you think if I is going up to the length of the board and we're on the 0j, then if I bring up the board, you can see the 0j would be this top row, and then if I can be anything up to the sides of the board, obviously that means we're going to traverse all of this edge. So the idea was we'd have something that would sweep all the edges all the way around and check basically, are there any ends on the edges, and if you are on the edge, so for example, if this red one goes here, then that's a bad example, hold on, if this red one goes here, then it's not going to move this one because it could go up or down, whereas this orange one, if this one went right here, it would move this one, it would move it up, because even though it can go up or it can go right, generally if you're going along the edge, you generally go like all the way around the edge. So that's not a definite rule, hence why this is a riskier method, but generally if you're already going around the edge, you generally go around until you hit an obstacle and then turn inwards. So yeah, that's what I tried to add here, and I was just wondering how it worked. So yeah, checking the I0 checks the top row, checking the I and then size of board -1 checks the bottom row, checking 0I checks the left hand side of the board, and then checking size of board -1 and then I, that checks the right hand side of the board. So I'm not going to read through this line by line, but basically each chunk is just copy pasted with like slight changes to the indexes that basically says if the if there is a copy of you like right next to you, so if we go back to the board, it's pretty easy to show. So it would check that this was an end, it'd find this end, and it would say, right, if there is you're now like a lowercase o, if there is a capital O behind you, then move forward, and if there's one in front of you, then move backwards, sort of thing. That's what that does, and it's basically just copy pasted with indices changed, like indexes changed, to get it to work on like the top, bottom, left and right sides. And yeah, that's about it really. So it just, oh, and then it's got this break in, so what it does is it makes one move, and as soon as it has found one single move to make, it then breaks out of this completely, returns the board now, and then tries to use like the non-riskier methods again. So basically it's relying on that one move being right. I did this because obviously the more moves you make, the more likely it is that it's wrong. So I wonder if we can find a level that it can solve. So we need a level that what I could do actually, if I comment out this bit right here, and then we save that. I am actually running some other code for what I plan on showing at the end, so we're just going to get that off, so there's no spoiler. Okay, so here and here. Now if we get stuck, we want to quit. It can now solve all of the 5x5s apparently, but I can't remember what the 5x5 was that I got stuck on before, so I'm going to leave that. I know there was some like 6x6 around, sort of this area that it couldn't solve. So we're going to have a go at these ones somewhere around here. So I'll just start from the beginning, we'll just see it working. This is obviously the bot as it was the last time you saw it, just with this end thing added, like where it connects the ends that are adjacent. Whoops. Why are we getting an error? Okay. I don't have the board in the right place. I can't actually show this then on video right now because basically when I changed which monitor I was on, I messed up. So what I'll do, I'll cut this off here, and I'll demonstrate in the next video. But basically, it ends up making mistakes, and I want to stop that. So what my plan is, if I just get rid of these, we can go back to the code. What my plan is I'm going to try and create an entire new program that will abandon all these methods and we'll just try and brute force solve boards. And basically the idea is it will solve any board at all that you throw at it, it will solve. But with it being brute force, it's probably going to take like forever to solve any decently sized board. I'm hoping we can get 5x5s done in a reasonable time, like 100% brute force, but I'm not sure how reasonable that is. So I want somewhere where we can say, right, here's a board now solved from this position, and my plan is that we'll, once I prove that that's doable and get that done, we'll add it into this, so into the solve board thing. So basically we'll run solve board, and then we'll have like our very last method will be, right, none of our cleverer algorithms are working, so let's just dump it into this this method that will solve any board, like this brute force, and let's just make a move and basically try and incorporate it that way, so that basically we get every board solved and it speeds it up because we already have all these like smarter methods. That's the aim anyway. So I have actually already started the code and it's working sort of, but I'm going to save that for the next video, so that's going to be it for this one. If you want to see that next video, obviously keep a lookout for it. It will be pretty soon after this one, I would imagine, just like the day after, something like that. So yeah, I will also have a little demo at the beginning of the next one showing the this code working, how I plan it, and like adding this and showing the mistakes and whatnot. So yeah, that's gonna be it for this video. Thanks for watching. If you want to see the next one, obviously subscribe, like, all that good stuff. So yeah, that's it for now. See you in the next one.